Alright, welcome to Lesson 10 Part 2, Graphing Quadratic Functions. Here we're going to go over some formal definitions, and I'm going to actually go over how to graph these quadratics. Now, this is going to be an extremely long video, a lot longer than any of the other ones before. I'm just going to warn you about that now. So you may not be able to finish this with your group in a single day, and that's fine. I wasn't planning on us to go through this in one day anyway. So, here's something similar to the first picture you saw in part 1. Here is a parabola. And here I have everything again indicated. We have our vertex, our x-intercepts, our y-intercept, and our line of symmetry. So if you remember, our vertex is the lowest or highest point. Our x-intercept is where it crosses the x-axis, y-intercept where it crosses the y-axis, and our line of symmetry is the line that goes through the vertex and where we can basically fold this over and it'll fold perfectly onto that part of the parabola. And here are the formal definitions. A parabola is a graph formed by a quadratic function. The vertex is the maximum or minimum point of the parabola. Your y-intercept is where the parabola crosses the y-axis, and sometimes this can actually be our vertex. And an x-intercept is the point or points where the parabola crosses the x-axis, and this can actually also be a vertex. So, back to the importance of that a term that we talked about in the first video. We have our y equals ax squared plus bx plus c, which is our quadratic function. And we saw that if a was a positive number, you saw that our parabola opens up. And if a is a negative number, then the parabola opens down. So that's what I wanted you to see in that first video. And another way you can think about it is if your a is positive, it's happy, it's smiling. So if your a is positive, your parabola is happy, so it looks like a smile. If your a is negative, it's sad, and your parabola looks like a frown. Something else that we looked at in the first video was what number a was. And if we found out that the absolute value of a was bigger than 1, your parabola gets thinner. If the absolute value of a is somewhere between 0 and 1, as in it's a fraction or a decimal, your parabola is going to get wider. Now onto the vertex. The vertex is very important. If your a equals a positive number, so if it's the smiling face, your vertex is the lowest point of your parabola. If your a is a negative number, then your vertex is the highest point. Did I mix those up? Positive a, vertex is lowest. Negative a, vertex is highest point. And then we have a formula to find the vertex. We start out by finding the x point, the x coordinate. We know that the x is going to equal negative b over 2a. The opposite of b over 2a, which if you remember is actually a part of the quadratic formula. So again, we took a part of the quadratic formula and we're using it. And then after we figure out what our x is, we substitute in that to the original to find our y. Alright, so again, we're going to use this expression, this little formula here, to find x, and then we're just going to plug that x into our function, and it's going to shoot us out a y. So, for these 4 examples, we're going to find the vertex and only the vertex, and I'll do the first one. So it's always easy just to identify what our A is, what our B is, and what our C is, just so we don't get working and forget. So we know that x equals negative b, opposite of b, however you want to say it, over 2a. Alright, so the opposite of b, our b is a negative 16, so the opposite of negative 16 is positive 16. And our a is 2, I should probably use the eraser. 2, so that gives us 16 over 4, so 4. So the x coordinate is going to be 4. Now we have to find the y, so all we do is we plug in. So y equals 2 times 4 squared minus 16 times 4 plus 33. Alright, let's simplify. 4 squared is 16. Simplifying this. 4 squared is 16. 16 times 2 is 32. So we can simplify this to 32. 16 times 4 is 64. So it's minus 64. So 32 minus 64 plus 33. And that gives us 1. So all those big numbers came out to a nice 1. So the vertex of this quadratic function would be 4, 1. So go ahead, pause the video, and work through the next 3 examples with your group. And here are the vertexes of all those. I didn't underline them all, so I'll go ahead and do that now. Go ahead and pause the video and double check that you got the same answers that I did, or see if I maybe made a mistake that you caught me on. Next we're going to talk about the graphing steps. Now they're not really very complicated at all. You've actually done step 1 already. It's just now we're going to put everything together. Again, it's not very complicated, it's just doing step by step by step. So the first step is to find the coordinates of the vertex, which we just practiced. Step 2 is just to plot the vertex, which we can do. We've been plotting points all year. Step 3, we're going to make an XY table. We're going to pick 2 x values that would be to the left of our vertex and 2 x values that would be to the right of our vertex. And then we're going to fill out our XY table using those new values. Then we're just going to plot all those points and connect them. So let's go to an example. So here we have the quadratic function y equals 2x squared. So here our a equals 2, our b equals 0, and our c equals 0. So step 1 is to find the vertex. So we know our x is going to be the opposite of b, so 0 over 2 times 2. And we know that it doesn't really matter here because anything you divide 0 by is going to be 0. We plug that in. Y equals 2 times 0 squared. It's also going to give us 0. So it looks like our vertex is at 0, 0. So let's plot that. And I'll plot this line in red. So go here to 0, 0 and put our vertex. And I'm also going to put it on this XY table. I'm going to put it in the middle. So we just did step 2. We don't actually have to write 2. We don't have to write the numbers at all. Step 3, we're going to make our XY table and we're going to pick our points. So 2 points to the left. So that means left means we're going smaller. So I'm just going to pick -1 and -2. and then 2 points to the right, 1 and 2. Then we just got to fill out the table and plot our points. So let's say that x equals -2, so y equals 2 times -2 squared, which gives us a positive 8. So it's going to be at -2, 8. X equals -1, so y equals 2 times -1 squared. That's going to be at positive 2. X equals 1. That's also going to be at 2. And then x equals 2. Gives us 8. So now let's plot the points. So -1, 2, -2, 8, (1, 2) and 2, 8. And then when we draw this, we want to try our best to make it look like a curve. We don't want to make it look like two lines coming out, so try to make it look like a curve as best you can. And there we go. Now before we move on, I want you to look at the line of symmetry. I want you to identify where the line of symmetry is with your group. Then I also want you to notice something about this XY table. What do you notice about -1 and 1 as the x values, -2 and 2? So go ahead, pause the video, and discuss with your group what you see and what you find interesting about this table. Alright. What I'm hoping that you saw was that if you notice, how far away is 0 from 1 and 0 from -1? Well, they're both one spot away. So they're the same distance away from your vertex. And you notice that their y values were exactly the same. Well, what about -2 and 2? They're both the same distance away from your vertex, and their y values are also the same. So that's where the line of symmetry comes into play through the vertex. Points that are the same distance away from the vertex on either side are going to have the same y value. So -3 and 3 would also have the same y values. That's why whenever you get better at plotting these quadratic functions, you'll be able to just recognize right away some of these things, and you won't have to plot and think about every single point. And by doing the XY chart, you'll be able just to look and plot. So here's another example where our B and C are here. So I'm going to identify my A equals -1, my B equals 2, and my C equals 1. So let's find the vertex. Opposite of B, so -2 over 2 times -1, -2 over -2, which gives me 1. Plug that in, so y equals -1 squared plus 2 times 1 plus 1. And if you remember, we did this vertex earlier, and it's actually 2. So we get 1, 2. So let's plot that. I'll plot this one in blue. So 1, 2. So here is my vertex. So I'm going to fill that in the XY chart. So it's at 1, 2. Alright, and I'm going to pick 2 to the left and 2 to the right. And I'm just going to go ahead and pick 0, -1, 2, 3. So now what I'm going to do is, since 0 and 2 are the same distance away from 1, whatever I get here will be the same here. So I only have to work out one of them because this happens. Now if they're not the same distance, then this won't work. And it's the same thing with negative 1 and 1 and 1 and 3. They're both 2 away on the x-axis. So this only works if they are the same distance away. And that's why I always try to pick points like that. Otherwise you just have to do some more work, and it's not really any harder. It just takes a little bit more time. So x equals 0. So we're going to have negative 0 squared plus 2 times 0 plus 1, and we figure out here that our y is going to equal 1, which means that at 2 it's also going to be 1. Then we do x equals negative 1, so we get negative 1 squared plus 2 times negative 1 plus 1. So we get negative 1 minus 2 plus 1 tells me that it's negative 2, which also tells me that it's a 3 negative 2. And something I did not talk about in the last example, but we'll go ahead and go back there now real fast, is everything we know about our parabolas we should also check. Like, should this be opening up? And yes, it should. If you look, we see that this is a positive 2. And if you notice, this parabola is kind of skinny. It's kind of thinner, which makes sense because we have a 2 here. So now let's look at this. We look at our A, and our A is a negative 1, which means that it should be going down. It should be opening down. So if we plot these points and it doesn't open down, we know we did something wrong. And then we see it's a 1 as our A, so it's probably not going to be very thin or very wide. It's going to look kind of normalish. So I'm going to plot the points and make sure that they are right. So 0, 1, negative 1, negative 2. Let's continue our lines. There we go. And it is opening down, and it does look like a regular size parabola. It's not very thin and it's not very wide. So it looks like we did this appropriately. Alright, and I have 2 examples for you to try with your group. So I want you to go ahead now and try them by pausing the video. Alright, and here is that example written out. And you do notice that with a fraction, you do have an issue of you may wind up with a fraction. And you should also note that on your XY table, you don't have to pick the same numbers that I do. You can pick any numbers so long as they are 2 to the left of your vertex and 2 to the right. And whenever you do put your numbers in the XY chart, I suggest you do use decimals instead of fractions, just because it's a lot easier to graph 0.5 or like 0.66 than it is to graph 2/3. So, one more example for you to try. So go ahead and work this example in your group. Alright, and here is the solution to that example. So go ahead and pause the video again and look this over with your group. And after you do that, the video is over. Finally, I know.